In this lesson, we will be going over some of the measurements made in the metric system and some of the units that you will use when reporting these measurements. So let's start by taking a look at some words that have something in common. See if you can identify what it is. We have parameter, odometer, diameter, barometer, and thermometer. All of these words have in common the fact that they end in the word meter. Meter is a suffix that means to measure, and we'll be coming back to that word meter later on. Next, we're going to compare some of the measurements made in the English system to those made in the metric system. So for example, we measure inches in America. In other countries, they measure length using a centimeter. We measure with feet, they measure with meters. We use pounds, they use kilograms. We use ounces, they use grams. We use gallons, they use liters. And we use miles as our primary length measurement when we're driving in a car. They use kilometers. One thing that's really great about the metric system that the English system does not have is that the metric system is a base 10 system. What this means is that all measurements made in this system and conversions between measurements will be made by multiplying by 10 or dividing by 10, or multiplying and dividing by some multiple of 10. The first metric unit that we will be discussing is the meter, which is the basic unit of length. A meter is a tiny bit longer than a yard. Now if we have 1,000 meters, what we call that is a kilometer. And this is one metric prefix that you should memorize is kilo. A kilo is 1,000 of anything. So if we have 1,000 liters, which we'll discuss later, we have a kiloliter. So a kilometer is 1,000 meters. A centimeter is smaller than a meter. A centimeter is 1/100th of a meter. What that means is 100 centimeters are equivalent to 1 meter. Now this should be very easy to remember because there are 100 cents in a dollar. The next prefix that you should remember is milli. Now if we have a millimeter, we have 1,000th of a meter. So there are 1,000 millimeters in a meter. And there are 10 millimeters in a centimeter. Mass is the next measurement that we'll be discussing. In grams is the basic metric unit of mass. And you'll see on the right-hand side of the screen, you have a triple beam balance and then a digital balance. These are both tools that are used to measure mass. Now just to review, a milligram is 1,000th of a gram, and a kilogram is equal to 1,000 grams. Just to give you an idea of the mass of 1 gram, a penny is equal to about 2.5 grams. So you should have a rough estimate as to how big a gram actually is. Now one thing a lot of people confuse is the difference between mass and weight. Now on Earth there really is no difference, but if you were to take something to the moon, you would know. You would be able to see very quickly the difference between mass and weight. So we're going to compare a 1 kilogram block on the Earth versus a 1 kilogram block on the moon. Now the Earth is much bigger than the moon and it has a greater gravitational pull. So the weight of that 1 kilogram block on the Earth is going to be far greater than the weight of that 1 kilogram mass block on the moon. Mass has nothing to do with gravitational pull. It's how much matter is in an object. Weight, on the other hand, depends on the gravitational pull of the environment. So if you're on the Earth, which is much more massive than the moon, you'll have a greater weight on the Earth than you would on the moon. And if you were on a planet that was even more massive than the Earth, you would have a weight that was even higher than you would if you were on the Earth. So mass stays the same and weight changes depending on the gravitational pull of the environment. Next up we have volume, and the basic metric unit of volume is the liter. The milliliter will be the most common unit that you will use in chemistry because that's what unit we use to measure liquids and many other volumes. Remember, there are 1,000 milliliters in a liter. Or 1 milliliter is equivalent to 1,000th of a liter. One thing you may not know is that 1 milliliter is equivalent to 1 cubic centimeter. You just use the units a little bit differently. When you're measuring the volume of a liquid, you'll use milliliter, and when you're measuring the volume of a solid, you'll use cubic centimeter. This brings us to density, which combines mass and volume. So say we have two boxes. One box will have a lot of dots in it, and the other box will have very few dots in it. One box will have more dot density than the other. And that's really what density is it's how closely the particles are packed together. So this one on the left has a high density, and this one on the right has a low density. Now the equation that we use to calculate density is this symbol rho, which represents density, and that is equal to the mass of an object over its volume. We can use any unit to measure mass, but most likely you are going to see grams as the unit to represent mass. You can also use any unit to represent the volume portion of the density calculation, but we will most commonly use milliliters or cubic centimeters. So grams per milliliter will be the unit that you will most likely use to represent the density of a liquid, and grams per cubic centimeter will most likely be used when representing the density of a solid. One interesting note about density is that the density of water is super easy to remember. It is equal to 1 gram per milliliter. The last measurement we will be discussing is the measurement of temperature, which can be measured in degrees Celsius or kelvins. Now we abbreviate degrees Celsius with this degree symbol and then a capital C, and we abbreviate kelvins with just a capital K. The thing about kelvins is that it's an absolute scale, and what this means is that the lowest possible temperature that you can achieve is 0 kelvins. This is equivalent to negative 273 degrees Celsius. So kelvins does not go into the negatives. That's what makes it an absolute scale. Now there's a little poem that I use to help remember the degrees Celsius and how it relates to an environment. So here it goes. 30 is hot, 20 is nice, 10 is cold, 0 is ice. Hopefully this will help you relate to the Celsius scale a little bit, and it will also help you remember that 0 degrees Celsius is the freezing point of water. On the flip side, the boiling point of water is 100 degrees Celsius. This is just one more way that the metric system makes things really easy to remember.